Okay, in this lecture we're going to talk about finding an expression for a function of x when we have the function expressed in a different form, like a y equals form, which is what we call an explicit form, or we have, say, something like 3x minus 5y equals 15. So this is the implicit form here because the y is part of this expression. And then we want to find f of negative 4 and f of r. All right, so to do this, all right, we want to rewrite this. Remember that we're talking about y being a function of x. So in other words, what we have here, that's going to imply then that simply we replace y with the function, and there it is. Now if I want f of negative 4, then this is simply going to be negative 4 squared minus 6 by negative 4 plus 5. So I end up with 16. Negative 6 by negative 4 is plus 24 plus 5. So this gives me, what's that, 30, 40, 45. Again, it's an ordered pair because this is really the y value, and when the x value is negative 4. When I want f of r, for example, that would simply be r squared minus 6r plus 5. Right, so that's how we do that particular type. Now in this case here, we first of all have to rearrange this to get it into explicit form here, y. So the first thing I need to do is subtract 3x from both sides. So we're really going to solve for y, so we end up with negative 5y is equal to negative 3x plus 15. Now I'm going to divide everything through by negative 5. So this is going to imply then that I have y is equal to 3/5 x, negative 5 into 15 is negative 3. So my function would in fact be 3 on 5 x subtract 3. So if I want f of negative 4, this will be 3 on 5 by negative 4 subtract 3, which will be negative 12 on 5 subtract 3. And this comes out, of course, 3 is 15 on 5, so it's going to be negative 15, negative 27 on 5. And of course, f of r is going to be equal to 3/5 r subtract 3. Right, so that's how we do those types of questions, writing things in functional notation. Now, the next thing I want to talk about is an increasing and decreasing. All right, increasing and decreasing intervals or functions. All right, and we want to know when they're increasing and when they're decreasing. Okay, so let's take a scenario, for example, where we have this kind of function. And we're always going to consider what happens as x increases in value. What do the y values or function values do? So in this case here, you'll notice that, let's suppose I take an x1 here and I take an x2 here. So if x1 is less than x2, but when I look at the function values, this is f of x1 and this is f of x2. Notice as it goes up to the right, the function values are increasing. F of x1 is less than f of x2. And this is when we have an increasing function. Now if I have this scenario where it's now going down to the right, again I can have my x1 here and my x2 here. Then this would be f of x1 and this would be f of x2. And you can see here that even though I have x1 still less than x2, I now have f of x1 is greater than f of x2. And so this is a decreasing function. Now the final scenario is this. What if I have a line that doesn't change in value? So we have an x1 here, an x2 here. So again, x1 is less than x2. But now I have f of x1 is equal to f of x2. Then notice that this, therefore, these don't change. So this is what we call a constant function. Now what we want to know is on what intervals is a function increasing or decreasing or constant. So for example, let's suppose I take this function with the value 2. In fact, this function is x squared plus 2. Alright, now in this case here, this is y, here's x. So our function values are here. Now notice that we're looking at what happens as x is moving this direction. And in this case here, it's coming down, so it's going down to the right until it gets to here. And so we can say that on the interval negative infinity to 0, because this is the origin here, we're talking about the x values, all right, from negative infinity to 0, we have that this is decreasing. However, as we continue this direction, it starts going up to the right, and so on 0 to infinity, it is increasing. Okay. All right, so there's an example of where a function is increasing and decreasing. And so let's have a look at some other types. So let's do example 1. So here's example 2, for example. Right, let's suppose I have a function that's like this. And 1, 2, 3 here. And then 1, 2, 3 here. So at this point here, all right, we had it doing this. Okay. Then 1, 2, 3. All right, so, and here's 3 again. So here's negative 3, 3. And here we have the point 3, 3. So it comes across like so. Right, and then at 3, 1, we have it do this. Right, so where is this function increasing, decreasing, or constant? All right, so let's have a look here. All right, remember we're always looking at x increasing here. So as x increases, what's the function do? Well, notice it's coming down, all right, to this point here. So from here on up to negative 3, so negative infinity to negative 3, okay, we're going to have that it is decreasing. Okay. So that's decreasing. Right, now what happens after that? All right, so in this case here, decreasing there, so we want to now look at what happens after that. Well, it goes constant, doesn't change value between here and here. All right, so it doesn't change value from 3, negative 3 I should say. Here's negative 3. All right, we don't have a value here, so we won't use that value, but after negative 3 it continues on until it gets to 3. All right. Now we have got 3, so it's constant at 3, so we have that. So this is where it's constant. Right, then what happens? Well, from here, not including the 3, onwards it is going to be increasing. Okay, and that's how we determine intervals where a function may be increasing or decreasing.